some of my previous videos, I kind of critiqued our scientific understanding of the Big Bang and cosmology. Although I don't hold a degree in such, I am being moved to say a few more things about this. Not mainly about the Big Bang, but about science in general. There is, within the scientific community and the academic societies and institutes, a certain amount of dogma that's starting to build up to the point where I believe it's hindering and choking deeper understanding of what could be found out about our universe. Now, I believe in the scientific method. I am a rationalist and a scientist at heart, but I've also come to the conclusion of not just believing and buying everything I am told, and either finding out firsthand if it truly has meaning to me and its validity. And there are scientists out there with this idea that have voiced it as well, such as Rupert Sheldrake. However, I don't think he's come to point out some of the real depths that science is lacking in. In one way, I'm reminded of what Terence McKenna used to say, that it's true enough. What I find very disturbing is that science, in many ways, is willing to stop at that. It works and it's true enough. Or as I've heard in the quantum mechanics field, don't ask questions, shut up and calculate. And what it's led to is a dogma approaching on religion of the scientific and academics to the point of excluding anything that could be more in understanding the truth and the nature of our universe. I will start again with the Big Bang as an example, and some of the insights or ideas I've had about it. I'm not sure whether this particular theory is true or not. I have my own views which I will not state here as they have been stated in my book more or less. But the presumption that it is true has been driving the community to pull rabbits out of its hat in order to make sure that the data and observations fit their model, to the point where they have created something called dark matter and dark energy, and when this didn't fit the entire bill, they decided to make up a cosmological constant that would just fit well enough so it'd all work out mathematically and great for them. But I think the insights they're missing is that they're not looking at the information that is out there with an open mind. And what I mean by this is, as I have stated, the lazy light theory to me fits the model quite well as the appearance of an expanding universe. Let's take this a step further. If we look out deep into space at a galaxy that's 2 billion light years away and it appears to be moving away from us, and then we look out 4 billion light years and see another galaxy that seems to be moving away from us faster. But those conclusions are based merely upon the light waves we're receiving. And it has to be taken into account that those light waves are 2 billion and 4 billion years old. At this moment, that galaxy that's 2 billion light years away that was moving away from us could be moving towards us, but in fact we would not know it for 2 billion years. It's simply a presumption that science is taking. And there's just so many more things out there that may be attributing to some of these factors. Now, science is very new at this in a sense that truly, we've only been looking deeply into space and discovering these things for the last 100 years. So us to set down a particular theory and say that's it stops many individuals that may look further. And here I'm going to give another example. And this being something that is obvious as it was proclaimed genius by the academic community when it was discovered to be true. And that's Einstein's theory of relativity and his ideas of space, time, and gravity. When he first promoted the ideas, it was scoffed. Then he did the mathematics and showed an example where it would be provable, and it was. And now it's accepted generally as the best theory of what it is doing. But do you think Einstein would have bothered looking for something more if he just bought Newton's idea of gravity and the way things were working at the time, which seemed to fit the models with a few anomalies? No, instead he said, let's look beyond that point and say that it isn't this way. What other way could it be? And continued his search. In so many ways, I think science is stopping some of the searching by proclaiming that this is it. We have it here. Here's our proofs. The experiment's done beforehand. It's taught in schools. It's bought as truth. And we go on from there. Now, I know science is built upon the information which comes beforehand. The point I'm making is that to truly understand it deeper, in particular fields, we may need to question the information, the experiments, and do them again. If something of interest to a scientist, they shouldn't just buy the first premise that was put there, even if it works great, because there may be more underlying understanding by keeping an open mind and looking further. This is just my observation of how science has come along so far, specifically within the academic and now ordained fields. And I'm glad for people like Rupert Sheldrake, and I'm sure there are many other scientists, as I know there are, that may keep an open mind to find new things as our understanding continues to expand. Here I'm going to also offer my view of some other subjects which are taboo within mainstream scientific communities because they're fed by the social and political dogmas which are restraining our abilities of discovering more about our universe and knowledge which could greatly assist the human experience and understanding. So here I would add things like some of the controversies over stem cell research based upon social and religious beliefs. Along with this, research into psychedelics and the true experience to discover what is going on. Now within the last field, I see some of the grips are starting to loosen, and I'm sure, or at least it is my hope, that as we progress in science, we won't so tightly hold on to restrictions that are socially, politically, or academically taboo. Just had to get this off my chest, and hopefully we'll reach some new scientists out there that are starting their academic careers, not to buy everything they're told, but if they're curious about it, investigate it anew, redo an experiment, make up a new one, look for the anomalies, and in this way we can find a lot more than just saying we already have the answer. Thank you.